Hello everyone, welcome to this video. In this video, we'll be solving this question which states that for each divisor k greater than 1 of n, right, we are given k as a divisor of n and we are given this set here UKN. Now what is this UKN? Let's understand it. We first of all know what is UN. It is a multiplicative group under the operation of multiplication modulo n, and it consists of all the integers which are less than n and are relatively prime to n. So suppose we are taking this u3 of 21. So first of all you will calculate what is u21. So it would consist of all the members less than 21 and relatively prime to 21. So it would contain 1, it would also contain 2, 3 would not be there and all its multiples would not be there. 4 would be there, right? Then 5 would be there, then 6 won't be there, 7 won't be there, right? 8, yes, it would be. Then 9, no. 10, yes. 11, 12, no. 13, yes. 14, yes. 15, no. 16, yes. 17, yes. 18, no. 19 and 20. Would it contain 20? Yes, it would. So these would be the elements present in U21. Apart from these, now what we have to do, we have to take each of these elements and apply this operation of x mod k. Now we are calculating the k, taking k as 3. So we have to perform this operation of x mod 3 onto each of these elements. So and whichever gives us 1, that would be present here. So 1 mod 3 would give you 1, 2 mod 3 won't, 4 mod 3 would give you 1. So here we have 4. 5 mod 3 would give you 2 and not 1. 8 mod 3 would give you how much? 2, not 1. 10 mod 3 would give you 1. So we have placed it over here. 11 mod 3 is how much? It is 2, right? It is not equal to 1. 13 mod 3 is how much? Well, it is 1. So we have kept it here. Then 14 mod 3, when you divide 14 by 3, you have 2 as the remainder, which is not equal to 2. 16 mod 3, yes, it gives us the remainder as 1, right? And 17 mod 3, it is giving us the remainder as 2, so we won't count it. 19 mod 3, it give you 1 as the remainder, right, when you divide it by 3. 20 mod 3 would give you 2 as the remainder, so we won't keep it here within this group. Similarly, what about u721? So we are looking for all those elements x such that x mod 7, this is equal to 1 here, right? So once you calculate it, you see that only the numbers 1 and 8 satisfy this condition, so we have kept it here. So this is the way how we perform this calculation. So now they are saying you have to calculate these 4 groups, right? These 4 sets, U420, U520, U530 and U1030. So first of all you should know what is U20 and U30. So let's first of all write down all the elements of U20. They are right this. Then once this is done, we are to calculate U4 of 20 and U5 of 20. So for U4 of 20, we are looking for all those x such that when you take x mod of 4, you get 1. And here we are looking for all the elements x such that when you take x mod 5 here, you get 1, right? So first of all, let's see this first case. In the first case, when you compute mod 4 of all these elements, you obtain it only for the member 1 and for the member 9 and for the member 13 and 17. So these 4 elements only give you the remainder as 1, others don't. So you see these 4 elements 1, 9, 13 and 17, they come into your set, and this is your answer. Similarly, for the second part, U5 of 20 is obtained when you calculate x mod of 5, and once you obtain 1, you kept that element within your set. So you see when you compute it for all these elements 1, 3, 7, 9, 11, 13, 17 and 19, right, you obtain 1 for the number 1, then for 11, just for these 2 members. So therefore you put these 2 within your set, right? What about the next one? For the next one, we have to compute it U5 of 30 and U10 of 30. So for that you require U30. So first of all, we list down the elements of U30 here. Once you know the elements of U30, let's now compute U5 of 30. So for that, you are looking for all such x such that x mod 5 give you 1, right? So we are computing it for all the elements here, you see, like this. So for each element here, when you compute it mod 5, you obtain 1 for 1, for 11, and for no other element. So you see, only these two elements are present within your U530, correct? In a similar manner, once you wanted to compute what is your U10 of 30, so you are looking for all those x's from U30 such that x mod 10 would give you 1 in this particular case, right? So once you do that, you compute mod 10 of all the members, so you see only 1 and 11 give you 1 as the remainder, right? So these two members are present within U10 of 30, correct? So this is one part of the question. For the second part of the question, we now have to prove that UKN is a subgroup of UN for the second part. So let's move ahead and solve this thing. So in order to prove that UKN is a subgroup of UN, it is sufficient to show that it is closed. So for closeness, what do? We take any two elements from the set and we prove that their composition, their multiplication is also present here. So what does it mean for AB to be present here? We first of all take its mod K, and then because they are already being taken from UN, there what is the operation? Mod N. So we also apply this mod N to it. So we have to, you see, this is a expression where you have to apply this operation of modulus twice, once with n and then with k, right? You get the answer as 1. So here in this case, we assume that a and b both are present in UKN. So what does it mean? It means that when you take its mod k, you would get 1 of both a and b, right? This is by the definition of UKN. This is how we have defined UKN. Now also we are given that k is a divisor of n. It is given to you in the statement of the question. So that means you can write n as k into t for some t, right? And moreover, if you have AB as some number and n as some number, you can divide both of them. So on dividing, whatever you get, that would be your quotient, and your remainder would be represented by r, such that your remainder would lie between 0 and n, right? It could either be equal to 0 or it is lying between 0 to n, right? So now we wanted to compute this and show that this is equal to 1. So for that, let's proceed with this statement. Here you see AB mod n. When you divide this AB, your AB is what? AB is equals to Qn plus R. So when you divide whole of this thing, AB with n, right, what you are doing, you are dividing whole of this thing with mod n. You are taking mod n of it. So when you divide this thing with n, it would completely be divisible by n. So it would give you the 0 as the remainder. And here, because it is not divisible by n, so you get r as the answer. So you have r here, r mod k. Right, now instead of writing this r, you can write from this expression again the value AB minus Qn, right here. And now you can replace this n with kt, which we have used over here, correct? So AB minus QKT mod k, this would give you, now once you take its mod k, again by using the same expression, because this is completely divisible by k, so it would give you 0 as the remainder. So this term won't make any effect. So you only are left with AB mod k. And you can separate this now. You can write it like this: a mod k and b mod k, both the values are equal to 1, so their product is also equal to 1. So this is what we have wanted to prove. So that means this AB now belongs to UKN. If that is so, this UKN forms a subgroup of UN. This proves the second part of the question. Now coming to the third part here, they say that if H is given to be a set which consists of all those elements of U10 such that x mod 3 is 1, then they are asking you to check that whether this is a subgroup of U10 or not. Now you see, you have proved it for a subgroup of you have proved that UKN is a subgroup of UN whenever k was the divisor of n. In this case, you are given 3, right, mod 3. So actually what is this? This is your U3 of 10, right? So now 3 is not a divisor of 10. So what can you say about this? So this example shows the counter example that this is not true for every subgroup. UKN is a subgroup of UN. This is not true for every subgroup. This is only true for the divisors K of n, right? So let's prove it over here. For the third part, we are given H as this. So first of all, let's write down all the elements of U10. They are 1, 3, 7 and 9. This you know. The operation is multiplication modulo 10. H is nothing but U3 10 by the definition, and once you compute it mod 3 of all the elements, you only have 1 and 7 here present within H. Now in order to check that this is a subgroup, we have to check the closedness property here, right? So obviously 1 into 1 is 1, which is present in H. What about 7 into 7? 7 into 7 is 49. So once you compute 49 mod 10, it would be what? It would be 9, which is present in UN, but we are checking it for H. So we have to calculate mod 3 of it, which is 0 and not equal to 1, right? So therefore in this case we say this is not a subgroup of U10. Why? Because this is not closed under the given operation, right? If that is so, then we say this is not a subgroup of U10, correct? So this is it for this question. Thank you for watching.